I'm actually a trooper. I'm a researcher. I work in the lab and collect data on the impact of ocean acidification and other stressors on marine species. But over the last years, I realized that if I really wanted to have an impact, I had to be more than a scientist. So I invest more and more of my time in other things like communication to different stakeholders. We make research on how to communicate better. And also I invest a lot of time in communication to capacity building. So I will talk a little bit of all of this in the context of ocean acidification now. So how many of you have heard before this day about ocean acidification? Can you raise your hand? All right, so it's still a lot of you that actually has to learn about it. So that will be my job for the next 20 minutes. I will try to explain what it is, what it's important, and what we can do about it. So again, I'm going to repeat a lot of things that has been said today, but this is basically the issue. We are more and more people on the planet. We are 7.6 billion today. Just to put things into perspective, there are 2 times more people on Earth since I was born, and I'm not that old, right? So we are more and more people. It's getting crazy now. I think we're 7.6, and of course it's not without consequences because people need to be fed, people need to be transported, needs to get jobs and so on. And because of that, because we are all these activities today, energy is related to carbon dioxide in many ways by burning fossil fuels. All this is impacting the climate, is impacting the world in many ways. And we know all the consequences of that. You have climate change, you have extreme events, you have change in chemistry in the ocean. And the ocean acidification is just another consequences of our carbon dioxide emission. And if you need to understand what ocean acidification is, you need to do one thing, understand this equation. So it's very simple chemistry. If you put more carbon dioxide into the atmosphere, 1/3 ends into the ocean. And if you mix carbon dioxide with water, it turns into carbonic acid. And that's basically, in a nutshell, what ocean acidification is. And that's much simpler to understand that the relationship between carbon dioxide and climate. And that's why it's also a good communication strategy to tackle the same issue, carbon dioxide emission. And of course, it's a little bit more complicated than that, and I'm not going to explain in detail, but it's also changing many other things in the chemistry of water. So it's the carbonate chemistry, it's called. So the seawater is getting more acidic, but also different breaks that organisms use for different purposes, like to build their shell, for example, is also changing. So you have less bicarbonate ions that some organisms use to build their shell. So because of all these changes, scientists started to be worried about what will be the consequences for marine ecosystems. And it's not just something we predict, that ocean acidification is happening right now. And it's been measured all around the world now. So the scientists go in the field and monitor the carbonate chemistry and measure pH, for example, which is the measure of acidity. And this is one of the classic graphs. You can see in red, that's the increase of carbon dioxide into the atmosphere. Below in yellow, this is the increase of carbon dioxide into the water. And in blue is the decrease in pH, so the change in acidity. So the ocean is getting more acidic. And the reason why scientists are worried is that graph. You can see the time scale is like 20 million years, and what you can see is the measure of the acidity of the ocean, pH. And you can see that on average on Earth, the pH of the ocean has been very stable, like it's around 8.1, 8.2, and it didn't really change that much over the last 20 million years. But what's happening now is this fast decrease that you can see there. So it's basically changing extremely rapidly. It's faster than anything that happened in the last 100 million years. Okay, so by the end of this century, we expect that the ocean will be 2 times more acidic than it is today. And the problem is that the organisms, the ecosystem out there, they are not ready for that. They are not prepared for the changes to come. So we know that ocean acidification is real. It's happening, it's fast, it's extremely strong, and it's happening all around the world, and it's directly related to our carbon dioxide emission. And just to scare you a little bit, I will start with the scary part and finish with the positive part. The last time that something similar happened, that what we are doing today to the planet as humans, it was one of the biggest extinctions on Earth. So when we had climate change, when we had ocean acidification happening, the last time, it was at the end of the Permian, and 92% of all marine species disappeared. And I'm not saying that it's what's going to happen, but we have reason to be worried because what's happening today, it's even faster than what happened at the time. So if we go back in the past and see similar conditions, it was linked to big extinction. And then you have work that has been done in the lab. So we have thousands and thousands of scientists working on that issue. And what they see is that if you culture organisms, and it's a wide range of organisms from bacteria to fish, here I've put like a phytoplankton on the left, oysters and coral reefs, if you expose them to conditions that you can expect within 10, 20, 50, 100 years, so a change in ocean chemistry, many of them, they just don't like it at all. So they grow slower, they have problems to actually build their shells, and some of them just die. And just to give you one example of a dramatic consequences, this is something called a Brittle Star. And that's what is called a keystone species. That's a species that is extremely important in some ecosystems. If you go dive where I live, around 20, 30 meters, you have thousands of these per square meter. If you expose their larvae to conditions you can expect in 20, 30 years from now, they all die within 8 days. So it's so fast, so brutal, that there is very little chance that actually we'll be able to adapt to this change. So you can expect that if we don't cut our carbon dioxide emission, these guys are gone within a few decades. And if they are gone, there will be a lot of other species that depends on them because they are forming a habitat, they are food source, that will be also negatively impacted. Of course, it's not black and white. Some species, they cope very well into future conditions, some other don't. So if you make kind of a summary of what is known today, 50% of all the marine species tested respond negatively to ocean acidification. The other one, they do fine, and some even do better. But on average, 50% is a large number. So we have really good reason to be worried because they will have consequences. Sometimes it's really hard to predict what kind of consequences, what exactly what's going to happen out here, for example. But there will be consequences. There is no doubt about that. And even worse, it's already happening. So there's a story about what happened recently on the west coast of the US, where in 2005, they realized that they had problems. The oyster industry had problems to produce a little spat, so the little baby oysters they needed for aquaculture, and they couldn't explain why. So they asked scientists to come around, and they checked for all the usual suspects like disease and so on, and nothing was really explaining why these baby oysters were dying. And then somebody realized that it was related to ocean acidification. And the whole industry was crashing there because of this. Fortunately, it was an electroshock, and there was a really strong political reaction, implementation of different solutions, including new ways of producing the spat, like doing it in other places, changing the aquaculture production system, and the economy was restored. So just to show that we have reason to be worried, but sometimes you can also work on solution. So we know it's happening. We know that there will be consequences, and there already are consequences of this for marine species and ecosystems. So it's really something that is of growing concern. And we heard this morning about the SDGs, the Sustainable Developmental Goals. And one of the sub-goals, the 14.3, is about specifically addressing ocean acidification. So that's something that the scientific community took really seriously over the last 2 decades, and now it's reaching the other level, and they try to have implementation of solution at the policy level. So that's where we are standing right now. So we are these little guys here facing like a major challenge, and when you're facing a challenge like that, you have 3 options. You fight, you flight, or you wait. Wait doesn't seem like a great solution in that case. It's going to end badly. But then you can work with the both other options. You can fight, escape, or you can flight, get rid of the problem, or flight, escape, and try to wait and see what's going to happen, or try to work on the solution. And when it comes to ocean acidification and many of the other issues we talked about this morning is the same. We can work on the cause, decrease carbon dioxide emission, or work on coping with the changes to come. And in a way, we have to work on both. I mean, if you work on the consequences, it's called adaptation. It's not going to solve the problem, but that will allow us to buy some time to actually cope with the real issue, which is decreased carbon dioxide emission. So on one side, you want to work toward decreased carbon dioxide emission. And we talked about that today already. There are many things that can be done. But when it comes to the science, we know more than enough today. We don't need more science to convince policymakers or anyone that we have a problem. We know that if we keep producing carbon dioxide as we do, there will be consequences. And if you check one of the big reports, the IPCC report that was published a few years ago, the phrasing used by scientists is that they are virtually certain that there will be dramatic consequences. And virtually certain is the more certain the scientists can be. So we know we have a problem, and you know what to do, right? We know we have to control population. We know, or one way or another, we know we have to decrease carbon dioxide emissions. So what is the frustrating part is, why is it not happening faster? Because it has to happen as fast as we can. And one of the issues is probably human behavior. And I was really inspired by the quote from Ken Caldeira from Stanford when he said, people have to sacrifice a little bit of their short-term self-interest to help the world be a better place for the long term. And how you get people to do that is the most important research that can be done. And that was a shift for me. I decided, no, I'm going to do is work on that. I want to do research on how we can make people change. And that's a question of collective action. How do you make people change on the global scale to cope with such a big problem? And one part of this problem is the communication. And we talked a lot about that. There had at the moment a session about ocean literacy and communication. And I really like the quote from this guy, Tim Minchin, he's an Australian comedian. He said that the idea that the science of anthropogenic global warming is controversial is a powerful indicator of the extent of our failure to communicate. So what are we doing wrong? Because we have a lot of scientists creating really good data out there, showing really clearly that there will be consequences of our carbon dioxide emission, but still it's not happening as fast as we would like. And I would say as a scientist, I can self-reflect on that. On one side, we are poor communicators sometimes. We just don't know how to do it because we are not trained to be communicators. And on the other part, we tend to be nerds, okay? We get excited about things that nobody cares about, right? I can talk for hours about sea urchin and invertebrates, and you would be bored to death. I think it's really exciting, but I'm probably the only one. So that makes me think, what do we need to do is probably reconnect with our audience in a better way. Because the way we do science communication in general is that we have a problem like ocean acidification. We create data, we create information, okay? And then we pass this information to society. And we hope that that will drive the change. Unfortunately, social science said that doesn't work, okay? Information is the worst driver of change. And even worse, that can create more polarization. So if you're more educated sometimes, we just use this information to reinforce your point of view, okay? So what kind of information do we need to actually drive the change? And what we need to do is shift the way we do science. And I will show you an example about ocean acidification. So in general, the science we do is like the point up there, where you have highly complex science on things that nobody cares about. And what we need to do is move to like science on things people care about that are quite good quality. And so I was reflecting on that and doing my science, on invertebrates and so on. And I said, like, how can I make ocean acidification important to people? So we sent social scientists in the field and asking people in the street, what do you care about in the ocean? And the answer in Sweden, where I live, is jellyfish. They hate jellyfish because you have these blooms and then you can't swim. In summer, it's really annoying. And seafood, of course. They really love their seafood. The Bohuslän coast where I live, supposed to be one of the best seafood in Scandinavia. So people travel there to eat it. You have fantastic lobsters, but then you have one species that every Swedes love is this shrimp. Okay, it's the northern shrimp, it's called. And the northern shrimp is really tasty, and you have this sandwich in every restaurant in Sweden. So I thought, like, okay, I can study that shrimp. I can study the impact of ocean acidification on shrimp and see what I have. But most of the time, what I would have done is study growth, metabolism, and things like that. And again, publish a nice paper, and nobody will care about that, right? What people care about is it tasting good, right? So I did an experiment like that. I just exposed the shrimp to conditions you can expect in the future. I asked the chef to cook them, and then I asked people to taste without telling them what they were testing, right? And I asked them, okay, can you tell me which one you prefer and why and so on? And believe it or not, you can taste ocean acidification. So that's just a complex graph, but forget about it. But just saying that if you ask people to taste them, they will say they like less the shrimp of the future compared to the shrimp of today. So I published that, and then I thought that that's the best communication opportunity ever. Because first, I can attract people interested by something they care about, which is food. So they come and taste and realize, oh, I don't like that one very much, so why is that? And then you can talk to them. That is because of ocean acidification, which is a consequence of the way you live every day. You produce carbon dioxide, so maybe, and then most of the time the reaction is like, what can I do about it, right? And that's what you want. You want people to be engaged by a physical experience, so realizing physically something that is invisible, because you can't see ocean acidification. It's a chemical change. So what we did first was a press release, of course, and we tried to have catchy quotes, like ocean acidification is often referred as the silent storm because you can't see it, you can't hear it, you can't smell it, but research suggests that you will be able to taste it. And I waited Christmas to release that because people, are in holidays, they read the news and they eat seafood. And it was a big success, of course. I mean, it was translated in many different languages. It was picked up by the scientists in the journal Science and many others. So it worked. I think it was a fantastic communication opportunity. It was really visible for a very simple experiment that I did just on the side of my regular job. But then what you want to know is that, does that make any difference? Will that make people change their behavior? And that's what we are testing right now. So we compare like normal communication strategy where you just present facts, information, ossification will impact that, okay? And then the other one was starting with the shrimps. So people taste it and, oh, what's wrong? And then you, in both cases, we asked them, okay, are you willing now to take a pledge for the environment? And we offered simple things that you can do in your everyday life, like, are you okay to cut your meat consumption by half? Are you okay to unplug all your electronic devices when you don't use them? Simple things that actually make a real difference. And at the end of this year, what I'm going to do is actually contact these guys and see if they actually did it, yes or no. And we will see if this kind of strategy works. So that was kind of a funny little story. But basically, we know more than enough about the consequences of ocean acidification on our ocean to know that we have to do something about it. And maybe what we need to improve a little bit is the way we communicate it. But then there's this other side of what you can do. So you can, on one side, work on the cause, so decrease carbon dioxide emission. On the other hand, you can try to adapt to the changes to come. And that's equally important because that helps us to buy some time to cope with carbon dioxide emission. And this is a picture from an oyster farmer in Hong Kong. So these guys, that's their only source of income. They live on rafts. They have really tough conditions. It's a tradition that's been running for centuries, and they lose their business. Not only because of ocean acidification, it's also because of pollution and other stressors. But these guys, if we don't help them, they won't have any job within a couple of years. So it's also our duty as scientists, I think, to actually try to develop solutions for people like this. And there are options. There are many things that actually could be done to buy some time. And for example, you can change practices in the way you do aquaculture. And that's the example of the oysters on the west coast of the US, where they change the way they produce their spats. And that works. You can also work on other methods that have been proved to increase ecosystem resilience. We had this morning a discussion about MPAs, marine protected areas. Another interesting thing you can do is work on other sources of stress, because acidification is one of the many stressors that occurs in the real world. And if you can't tackle one stress, it's good to work on the other one, because the less stress you have, the more you can cope with additional problems. Another interesting approach is doing something we did on land for decades, is select strains, for aquaculture. Why not selecting strains that are actually ready for the changes to come? So that's an approach that's studied for aquaculture. Again, you can have oyster resilient to ocean acidification and other stress, and so on. But most of the time, when you want to implement local solution, the problem is that you need data. You need to understand what will be the consequence, what's the problem, and it's changing, it's different all around the world. So ocean acidification is a global problem, but with a local perspective. Acidification is not happening in the same way here and in Sweden and in Africa. And the problem is that we have a lot of data around here, but when it comes to certain continent, we know nothing. For example, the African continent, there is very little monitoring program, so we don't really know what's happening there. So if we want to help these countries, the first thing we need to do is help them to get the data we need to be able to develop the solution they need. And to do that, we started first by evaluating what they need. And because I was first starting this capacity building program, teaching as I always do, and I arrive in an African country where they say, like, it's really nice what you're presenting here, but there's no way we can implement that. We don't have the equipment, we don't have the money, and so on. And then we started by making an evaluation of what they need, and this is like an incomplete map, but the color is very simple. Green is that they have everything they need to start working on ocean acidification. Today, red means they have nothing. And by nothing, it's not even stable electricity sometimes. Okay, so they don't even have labs and so on. So how can you start measuring impacts or monitoring in places where you have so little? And that's why we started now to develop like a capacity building program based on solidarity, so trying to have people helping each other. And it's for a 3 steps program, really. First, we try to evaluate what is needed. Then we try to develop the technology, to simplify technology to actually make the work happen. And then we implement. So we go there, build labs. So this is an example of a lab I've built in Mozambique. So the room on the left, on the top left, is how it was when I arrived. That was the first time they were plugging electricity in the lab. So they plugged the electricity the day before I arrived. And then in a week with the locals, we basically built a very simple lab, but efficient. We could do the first measurement, the first experiment within that week, and now it's been ongoing since then. So that can work, okay? It takes energy and time. And most of the time when you go there, they are full of passion. They want things to happen. It's just a question of having the possibility of doing it. And we try to communicate this passion. We created networks where people can help each other. And it works. And an example of an activity that cost nothing and had a huge impact is something we did during the Ocean Day this year. So we organized an ocean acidification day where scientists from all over Africa measured the acidity of the ocean at the same time, and it was used as a communication strategy on social media and so on. So that helped raising awareness, that helps raising interest from local policymakers and try to continue the development of marine research in their countries. And I'm really pleased that actually this program of capacity building is getting more and more attention. And through the conference in New York at the same time of the Ocean Day, we had at least 2 commitments for more than $1.2 million to keep this capacity building program ongoing. So my conclusion is ocean acidification is really real. It's something happening. There is no doubt about this at all. So there is no place for skepticism or denial. It's happening. It's directly related to our carbon dioxide emission. We know as a fact that there will be consequences, negative consequences for things we care about and we like. We know more than enough to use that as an argument to cope with the carbon dioxide problem, but we need to be better communicators and maybe rethink a little bit the way we do science to collect the real data that will influence society. And there are solutions. There are local solutions, so we can actually start collecting the data, develop local solutions, but that will require some time also building capacities in some countries to do so. And I will just end with this slide. So people in other rooms around here are talking about solutions now. That doesn't mean that we can't contribute. So that's just a few thoughts about what we can do as citizens in this room. So we can try to be better citizens, and the charter that has been developed here actually will be instrumental, I think, in giving ideas about what can be done. You can also be citizen scientists sometime, and many of you in the room, you like sailing. And one thing that could be done is you could help collect data. You go to places where scientists never go. And you can actually have the chance to collect some data that would help us to actually have a better mapping of the world. You can also be ambassador. You can, every time you go, talk about what you've learned during these 2 days, communicate, try to be, be part of the change. And of course, solidarity is key. I mean, I try to invest a lot of my time in going to different places to teach, to build lab and so on, to attract support, money and so on. So all these aspects are really important, okay? You can be better citizens, you can actually help science collecting data, you can contribute in many other ways. And I will end with a quote from Tom York about the ocean. And the reason why we are all here is because we are passionate about the ocean, and we should capitalize on this passion to make the world a better place.